Okay, welcome everyone. My voice doesn't normally sound like this, apparently. Talking all night for 3 days in a row before you give a speech isn't the best. But
Here we are. We made it.
here we are. So, who are we? My name is Brian Heemskirk. I'm the art director at Massive Damage.
Hi, I'm Sora Moore. I'm the technical director of gameplay.
So, for those that don't know who we are, so we work for a company called Massive Damage, which was founded in 2010. It's fully remote. It started out as a mobile company working primarily in Unity. So they shipped games like Shadow Wars, Please Stay Calm, did fairly well for them. But at a certain point, they were interested in shifting towards indie and away from mobile development. So that started with a game called Halcyon 6, Starbase Commander. So I did half of the pixel art for this game, came on halfway through production. It was very successful for us. It got to top slot on Steam, was played by quite a few people. We also shipped another game called Star Renegades. This was kind of our entry into 3D. So all the characters and assets were 2D, but they were assembled in three-dimensional spaces. We had used post-processing, real-time lighting, and a lot of things like that in making the visuals come to life. So I did all of the pixel art for this game, backgrounds, characters, animations, stuff like that. And we had giant sprites with 200 to 300, 400 frames of animation, and I tormented myself over and over and over and over again.
How much RAM did you use?
We're not going to talk about the RAM. Okay. So giant sprite sheets in Unity, lots of fun, a good foray into 3D. This is our current project that we just shipped early access. So today I'm going to tell you a bit of a story of this game, what happened in its development, because it's quite the story, the ride. 1 second. So Fera was a third-person action survival game, open world, co-op multiplayer, village simulation, aerial traversal and combat, huge monsters, just, every problem you could decide to face yourself for
For a first Unreal project.
yeah, so, and then that launched to early access fall 2024. Took about 2.5 years to develop with a team of just over 20 people and was done fully internally. So, awesome. This is some of the concepts I did when we were trying to come up with the world for this game. So, setting, feeling, what might be useful and what would work with what we wanted to do in terms of big creatures and whatnot. But this isn't the beginning of the story. So the high-level look of our talk is we're looking into the art direction, how we discovered our visual style, what kind of technical challenges those created.
I'm speaking to the technical direction, mostly digging into how the design and programming teams worked with Unreal to create Fera. Really, what advantages the engine gave us, and some production landmines we encountered.
Yeah. Awesome. So why this talk? We started in Unity, we moved in Unreal. We split our development kind of halfway between the two. At the time, we had almost no Unreal experience. And what would we do if we had to do some of these things again? All right. So this talk is for small teams, new to Unreal, anyone in leadership, studio directors, production, product owners, project management, any technical leads, and I guess art and any artists or whatnot that might be interested as well. Why did we switch to Unreal? This is a big story when it comes to us. We found it was the best fit for Fera's vision. It let us focus on PC and console games. So if we wanted to do simultaneous shipping or things like that, those things open up to us. And we found the talent pool was growing more and more in that direction. And also interesting technologies. You watch a lot of the latest announcements. We were here for a keynote where they mentioned, hey, all of these features. And you're like, I want to use all of these. So things like that. This is where this project started. So right after we shipped Star Renegades, it was an idea for a guild sim that you played. It was kind of like playing a fake MMO, and this was the initial concept for it, and this is the first art I did for this game at all. So it was using our Star Renegades engine, and I pulled in a bunch of silly assets that I just drew on the fly to see what might be a fun space to play around in. That evolved, though. So from there, we started thinking, hey, what should this look like? Do we want like cute, simplistic characters? Do we want something more Bravely Default or Wind Waker-esque, or maybe more Breath of the Wild, Tears of the Kingdom-esque? Tears of the Kingdom was not out at the time. What does that look like as you scale into different armor sets and things like that? And then these are some concepts of what maybe that would have looked like if we progressed in that direction. And we did for a year. We continued to progress in the direction of this game. So working out different classes, things in that style, what maybe some enemies would look like in that world, and we mocked up and had the entire thing running in Unity. So we built those sets, those assets, what that game could potentially have looked like.
A lifetime ago.
It was. It was a mixture of almost like an Animal Crossing / Diablo-esque type game. And of course it had chickens, because you need chickens. Yeah. Here's some videos of those prototypes running. So we had it working in engine. It was 4-player playable. You could play with your friends. And anyways, we had internal demos and all running in Unity. And yeah, that's basically where this project... Oh, there's one more video. Play. There we go. So you can see stylistically what I was trying to go for in the Unity space with that. We kept adding plugins to work with it, and there's a funny thing about the plugins that we were working in with Unity is all of them were just doing things that Unreal already had. So when we incorporated Microsplat, it was to help us paint terrains into multiple layers, have more deformation tools on them. Tail Animator was for physics on cloth, and then Fluff was for fur and that kind of simulation. So we were managing plugins and trying to manage them as versions change in Unity, and at the same time, all of those things were just ever present in Unreal.
Nothing went wrong.
The concept started changing, though. So we were developing that. There's a silly painting I did of a giant monster. We started moving into maybe the idea that you fought against bigger beasts and had co-op with your friends, playing with those. And, you know, like any pivot in the game industry, it feels a little bit like you're being hung upside down. So we started pivoting with the art style of the game. We went to a slightly more Breath of the Wild-ish, maybe, you know, with some Shadow of the Colossus and other influences that we were doing. We modeled these characters out, started playing with stylization and ZBrush and Marmoset, getting assets the way we wanted, and we built all of this in Unity at this point in time. So we had a playable demo where you could use these characters and these locations and spaces all in Unity. So a bit backstory to me before I go to the next slide. I typically asked for us to change to Unreal before each game. So when we went to go to Star Renegades, I'm like, hey, we should do this in Unreal. When we went to do the first version, I'm like, hey, it's a good time to switch to Unreal. When you're learning, there's lower risk. And I would say that for about 4 or 5 weeks at the beginning of a project, and then I'd shut up because I don't want to step on any toes. I just, you know, when you're learning and whatnot, it's an opportunity for change. So anyways, I was known to be very vocal about that in that window, and then I'd quiet down afterwards. And this is the initial, so this is the Unity video that we had running. It was all playable. But my bosses kept referencing things at me. They'd say, hey, can you do water, like Call of the Sea? Or some stylized things, like what I'm seeing in Final Fantasy VII Remastered. Or the volumetric fog that you see in Returnal, and this from this. And I kept telling them over and over again, those games are made in Unreal. Those games are made in Unreal. And I was getting frustrated. So what happened was, my one boss is like, well, if Unreal is so much better, show us. And we had learning days, so half of the day on Friday we could do whatever research or whatnot that we wanted. So my boss said, use your learning day and show me if it's so much better. So I took the exact same two assets, and on the left you can see, those are the assets just as they are running in Unity. And I put those same assets and materials, rebuilt them in Unreal. Identical assets, identical material setup, just how the engine handles lights. When I was working in Unity a lot, I would do weird things like set parameters on how little or how much a light could affect characters and set them to layers so that I can mix it to look closer to the way that I want. And when I worked in Unreal, I found that the lighting was all I had to play around with. Move lights to the right places, put lights in other places, and play around with it. And I really enjoyed that aspect of development. We looked into stylization with the two engines. Hey, I pulled in ramp shaders and whatnot, played with rim lighting and such like that, and we tested the Unity on the left there, trying that, and even Unreal on the right to see how that would look and play out in a three-dimensional space. So testing the engines, seeing what suits our vision of the game, so on and so forth. So where we ended up, here's concepts I threw together as we were getting ready to move to Unreal of characters, locations, potentially we can make. And this is a mock-up painting I did for what maybe a fight could look like in this space. And then we went to Unreal trying to get as close as we possibly could with the resources we had. We didn't have that other monster modeled at the time, so we changed the monster. But anyways, basically, we built a custom shading model in Unreal. So we had to split off the branch a bit, and then we changed how lights behaved. So we were our game had a dynamic time of day system, so we needed to make sure that we wanted to use Lumen to make it easy for us to deal with that specifically. But Lumen caused some situations for us, very powerful, but with a stylized rendered approach, it meant that we had some particular challenges. So the big things we were trying to work with is having proper ramps and cascades on the character in indirect lighting, and how we handled rim light. So we built our own custom rim pipeline. Kenneth Lamb, really, really smart render tech, built this for us. So this is from him, so if I misspeak, I apologize, but it's calculated during the dynamic lighting accumulation, factoring in light color and any attenuation, and added to the total diffused light. So it looks at the primary light, and it looks at secondary lights, it can add them together, and then it calculates so that the limb is always appropriate color. When you have when you have games like Persona 5 or 3 Reload, because they have a static time of day, they can just set an extra light and do it and then get perfect rim lights. But for us, because we had dynamic, we were trying to get a stylistic effect similar to what they do with those games, but we had to come up with a different path to try to get our rim to match them. But the problem is that they accumulated. So sometimes they were extremely bright. Here's examples of us trying to figure out how to make this work. So you can see on the right side, that's with the lights accumulating too much, and you end up with a too harsh or whitish outline around the beast. And then on the left, you can see that it still exists and the rim's present, and it's related to the color, the secondary color of the environment, but it's not as intense. Indirect lighting. So we found we were able to get the ramps and things to work pretty well in direct lighting, but whenever indirect lighting came in, you get too much gradation on the characters. So we built a custom pass on the actual lighting to try to get more of this effect. So it was a challenge integrating Lumen indirect diffuse lighting. It canceled out our stylization on the lighting and the characters. So we applied a ramp to the luminous brightness of the indirect lighting value in the composition shader, was the method that we ended up doing to maintain more of the stylistic look, even in indirect lighting. Here is kind of a tech breakdown, courtesy Ryan Honey, who's one of our lead technical artists. So you can see some of the stuff that we incorporated into the game that's unique for our particular vision. So you can see a lot of dynamic grass, using RVTs for its color, swaying trees, and various things, using Unreal's features, but also we had to build our own versions and variations of it for this game. So I'm going to go and outline a couple of those specific features now. Okay, so our grass system. We built our own custom grass for deformation when you walk on it and displacement. Yeah. These are some of the features we were using. You can see the deformation in the grass as you walk through, and the beast as well as a larger window on it. If you have any interest in this, reach out to me and I can set you up with someone that implemented it. So some of what we used for our grass, we used a plugin initially for our water, but the render time on it was much, much too great. It looked great, but its render time was a bit excessive. So we had to build our own solution for interactive water and waterfalls that was much more lightweight. Okay, and we had instanced foliage destruction, which was a fun little thing. Used Niagara user data VFX and a lot of procedural volumes and stuff. This is an example of our instance foliage destruction. So you can break down trees, other players can break down trees, and also the monsters. You'll see that monster behind us tear down a few trees in a second.
Oh, come on, little guy. There you go.
Anyway, so these were features we were using Unreal's tool set and building our own where necessary to implement and get our game behaving the way that we wanted. But was a lot of fun in those regards. So this is examples of kind of how it all came together with trying to get Lumen and whatnot to behave. So we did much more stylization in our rendering to try to get the results looking the way that we want. Now I'm going to pass over to Sora.
Thank you. All right. Get to play with this thing now. Cool. All right, when it comes to technical direction, I want to dive into what working on Fera looked like in terms of how programming and design teams collaborated, specifically with how Unreal changed a lot of how we're working together compared to Unity. So let's start off by talking about blueprints. I imagine most of you are familiar, but for those that aren't, this is Unreal Engine's visual scripting language. And this was the biggest game changer for our team. It allowed our non-programmers to work in the engine and start prototyping features right away. And this is a great fit for us because, we're a very designer-led studio. We're not big on our tech. All right. For example, the user experience of village building, it came to life completely through blueprints. But for us, it was so much more than it means to prototype game mechanics. There we go. Sorry, Brian, I'm gonna screw up the jumping along the bottom.
No worries.
All right. Our animation team was able to animate this guy completely with no programmer support. Now, hopefully that raises some eyebrows among the programmers. We're gonna get to that. Blueprints were not limited to game features either. At one point, we had to rename a bunch of assets to match our style guide. To solve this, we built this editor tool completely in blueprints. And what's great is this let our non-programmer staff add features to it without needing to go to a programmer. In fact, the trim start, trim end, that was added completely by a tech animator mid-production. When it comes to VFX, there's lots of native tools and features, of course, but we had challenges wiring them up parametrically to our game mechanics. We often had cases where we would need to iterate on attack timing after the VFX was complete. So you can see with this laser attack, we wanted designers to be able to tune the timings on anticipation, on firing, on cooldown, while the VFX was being iterated on. We didn't want our tech artists spending time learning how the attacks were implemented. So let's dive a little deeper into that problem, by taking a look at one of our attacks. We all wear a lot of hats, massive damage. In this case, Brian was both creating visual concepts and designing our combat behavior. He sketched out some ideas for attacks, and we started with the ones we could do fairly quickly. So from here, our programmers and tech designers would block out the attack with placeholder VFX. I'm sorry, Mrs. Ranger. Then the blockout logic would be exposed, or we'd expose blockout logic for hooking the VFX into them. For the programmers in the audience, the goal was to create a layer of abstraction that lets the effects teams, or gives the effects teams a walled garden to iterate in. In this case, the artist had clear events for when the attack starts and when the shot fires from the tail. At this point, the blueprint is handed off to replace the placeholders, and now our design team can adjust the telegraph timing, number of shots, flight parameters, all without needing any effects revisions. Now, I'm hoping at some point the programmers in the audience are shaking their heads just a wee bit. This is for you. About halfway into production, a decision was made to have some smaller enemies to break up the combat pacing. The result was this little guy we called the Gooplin. Our animators wanted to create something that was a little more procedurally animated than a skeletal FK. And the designers were familiar enough with their enemies that they could inherit from existing blueprints for our enemies. After some time, the animation was tied into locomotion and it was ready for AI. I need to emphasize at this point in time, the programming team didn't know this was something in the pipeline. The art and design teams did this completely on their own. Awesome. Our studio was able to create a whole new enemy without any programmers. What could go wrong? For starters, performance problems. To locomote and conform to the ground, these actors used a lot of primitive traces every frame. This prevented our Gooplen from being scalable in high numbers, which, that's what they were built to do. That wasn't shippable, and the optimization cost at this point is unknown. Second, early QA found that the behavior were not synchronized in multiplayer. Underlying problems were because their hit detection AI systems were built from the ground up, as opposed to using the systems we built for our larger kaiju. Now, of course, this is all solvable with programmer time. We can migrate logic C++, we can time slice some things, we can refactor some hit detection systems. We did. That was fine. But we're getting away from the point, which is, for us, letting our designers lead the way was great, but there are trade-offs. We saved a lot of time not scoping requirements or building tools, but we encountered some other production problems. As our team was iterating and showing off their work, it started to create this culture of uncertainty in the team. Production and leadership didn't know how complete a feature was, let alone the work effort needed to finish it. If you're a technical lead, how do you know if this feature is scalable, maintainable, or even extensible if you just see it posted on Slack? And this is fair. You can't expect your non-programmers to fully understand what it takes to get a feature to a shippable state. Programmers and QA are needed to assess what's missing and scope the remaining work. This is a non-zero effort. Let's just say median technical director. I'm going to assume that most programmers would rather make stuff than read blueprints all day. Sometimes you get clean logic and it's okay, but sometimes you get blueprint spaghetti. And this gets worse when you're dealing with features that are already sold, either internally or externally. Like maybe they found their way to marketing materials or publisher milestones. At this point, your team might be committed to this feature no matter how difficult it is to fix. Frankly, with the stressful nature of game development and all this extra pressure we're under lately, this can turn into a real morale problem. Now, for us, there really wasn't any magic bullet. There was this concept we had of developer migration. This is where programmers would take ownership over designer work. We tried some formal processes to manage it, but none of it really stuck, and mostly because it just kept getting in the way of iteration. I mean, how many people have cycled through different process iterations of Agile? But, this is okay. We're a small team. We can approach these problems one by one. Of those solutions, the best ones tend to revolve around teaching and communication. Teaching our team to fish. Remember, we're fully remote, so good communication, it's a hard problem for us. This was our most consistent process. I can't believe I'm getting away with putting a Google Calendar on a slide. Every day from 4:30 to 5, our programmers would all hang out in a video call. And sometimes we talk, but most of the time we were quiet. And this very much had the same feeling as a programmer pod in an open office. But the key here is that anyone in the company was welcome to just jump in. Programmers were not always the easiest to approach, and there's a reason we all wear headphones in the office. So we were clear to everyone, this is not focus time, this is social time. And what we found was it started to build a culture of psychological safety in team building. There are no stupid questions. And it was, just nice to see people have some water cooler time. And finally, we found that it really built a sense how people actually felt about the work being done and the problems that were coming down the pipeline. It's the kind of thing you just don't really get in stand-ups, honestly. Stand-ups, they're designed to be fast. There's no room to discuss a problem or discuss why that problem is important at a creative level. And in a creative space, this is very important. When you make this dedicated time to let people talk at a problem, you start to get real communication. Some other things we tried. Fishing lessons. These were weekly one-on-one meetings between programmers and non-programmers. It was really worked out to be a time to pair program and sort of ask what problems you're focusing on and try to solve them together. This had some benefits, but we found it wasn't really scalable. It was more effective to just book the time as needed and kind of approach it one by one. We had a program called Show and Tell. These were bi-weekly meetings for tech artists and animators to link up with developers, just show off what you're working on, any questions you might have, show off some cool stuff you learned. It kind of turned into an informal code review. It was kind of a chance to share knowledge. But again, it's difficult to get everyone together. So again, just kind of schedule it wherever it made sense. I want to talk a bit about documentation. For the most part, our docs were all Google Docs. organized and aggregated on a Google site. I'd ballpark about a quarter of it we actually used, but that quarter was really critical to helping people solve problems, specifically workflow problems like source control, common engine troubleshooting, especially if we're onboarding new people. But our biggest weakness was trying to maintain this documentation specifically for gameplay tools. The features and the gameplay pivots, they were just happening way too fast to maintain the docs. But part of that also is we were a small team before. We were 10 people on Star Renegades and Halcyon 6. Now we're up to 20. And even though we doubled the team size, that relationship for communication gets exponential. Now, I know at this point I'm not quite selling the idea of a design-first studio. That's too fast. But let's consider the alternative. When we started in Unity, our development process kind of went like this. We meet, decide what we want to build, specifically the design team. Maybe there'd be some design docs, some wireframes, or just a list of bullet points. Programmers, they'd run off, they'd build the first iteration of the tools and features. Once they finish, there would be a period of knowledge transfer. And then finally, the designers can start iterating. But at this point, days or maybe even weeks have gone by between the designs of first iterations. We often found that designers would be blocked waiting for tools, and programmers would get blocked waiting for feedback on those tools. And what happens when you're blocked? You get sidetracked, you move on to something else, and then, everything starts to fall apart. With Unreal, we found that once we were a few months into production, the process more often went like this. Design team internally decides what they want to make, and at this point, they're familiar enough with the editor to start prototyping right away. Eventually, they might hit a technical wall or hit something the current tools couldn't do. And this is when the programming team gets involved. And what happens is, or what happened for us, is throughout production of the development of a feature, it felt like the team was working in parallel as opposed to waterfall. Now, let's look at this in practice. We'll dig a bit deeper into the engine features behind our movement and combat systems. The moment-to-moment gameplay of Fera's combat really comes together when you're fighting big kaiju. And this is centered around gliding and grappling to make space, manage your distance, avoid ranged attacks, find your opening, and strike at weak points. Now, not a lot of this was built from the ground up. We extended, pretty much all of it was extending existing frameworks. Let's look at the movement systems to start that. We landed on this pretty early in development. This was a back and forth between gliding and grappling. Your gliding costs stamina, but recovers energy as you're doing it. And while you're grappling, you're recovering stamina, but you're burning that energy. So you get this back and forth of flying and seeing how long you can stay in the air. And this was really fun. And best of all, it let us put the world and art direction front and center. Our movement systems, they were all built completely on top of the third-person sample project. We were able to start iterating on that game feel right away. Out of the box, you get walking, jumping, falling. You get all the physics that comes with this. This is your gravity, your collision, sliding along complex surfaces, even moving platforms. And best of all, multiplayer just works, with a big asterisk. The underlying architecture of the character movement systems is very complex. Well, it should be understood earlier, not later. We got way too hung up on game feel early and without considering the edge cases for multiplayer. As a result, I'd say a few months before launch, it took 3 developers a 6-week refactor period, which I'm sure your game director would love to hear. We ended up creating a number of custom movement modes. They're all backed by a finite state machine. So grappling, gliding, running, knockback, these were all modes that were based on the existing walking, falling, and flying behaviors that ship with the character movement component. We did use a mix of blueprints and C++. C++ was for low-level logic, sensitive to multiplayer restrictions, and blueprints were for more gameplay-driven logic and state transitions. So with grappling, our blueprints dictated when you lost your grapple, and C++ dictated how that state would be replicated in multiplayer. When it came to iterating on game feel, we exposed parameters and let designers tune those right in the engine. When it comes to combat, the challenge for us was finding the right layer of abstraction for our team. How do we let our designers and animators iterate on combat without constantly waiting for new features? Early on, we frequently would build the wrong tools, or it was a little too high level, or didn't provide enough flexibility. But for most of it, it was solved by the Gameplay Ability System plugin. You often hear it referred to as GAS. Almost all of our combat systems were built on top of this framework. This framework gives you a system for attributes, your health, your stamina, your mana, attack and defense stance. You get a system for status effects, so your buffs, your debuffs, damage over time, and even systems to create custom calculations for damage. You get gameplay abilities. These are self-contained logic for how an attack behaves and reacts to events and input over time and throughout execution of the ability. And it's not limited to attacks. Our grapple and dodge systems were abilities in addition to all of our melee weapon attacks. Finally, you get gameplay cues, and this is your system to trigger feedback and cosmetic effects. So your particles, your audio, your camera shake, your force feedback. And what you get is this layer of abstraction between what triggers your feedback and the feedback itself. This is great because team members now iterate on this feedback without even touching any gameplay assets. And best of all, prevents them from breaking gameplay logic. As a bonus, all these features are multiplayer ready. But I want to stress, this wasn't turnkey for our team. You do have to write a fair bit of C++ boilerplate. There is a plugin called Gas Companion we use that did most of it for us, and it was a great starting point. We were up and running probably a week or two once we started using Gas. But, as programmers, we're not done. Throughout the life of the project, we slowly built upon this layer for kind of our own version of it. This gave us some extra functionality and editor quality of life. When it comes to movement, if you want your abilities to have a lot of control over how the character moves and have it work in multiplayer, you gotta start working on that early. For Fera, you can see on the slide, we create a special movement mode. And the idea is that the movement mode would defer to the gameplay ability to drive how that character moves. This is also partially why we had that big refactor period. A good example of how this works is with our signature attack for the axe. The way that attack goes, from any falling or gliding state, you can start this ability. The player halts their motion, they briefly rise into the air, and they enter a special flying mode where they just move towards where the camera's pointing. And we wanted the designer to decide how this timing worked, how the speed worked, how it felt, how it got triggered, without having to talk to programmers. So after some work, this is what we ended up with for them. Within the editor, there's a means to hook up events called notifies to the animation timeline. And what you're seeing here is how our combat designers iterated on game feel once we got that refactor finished. The events in green all control how the character moves in a manner that's safely replicated for multiplayer. All right, we are almost done here. Before we move on to questions, I want to spend a few minutes to talk about game data. Show of hands, how many of you work with designers that live in Excel? Odds are, if you're a smaller team, this is your go-to solution. For Fera, most of the designer-owned data lives in data tables. These are Unreal assets that let you define a data structure for each table. With the right fields, you can create something like a relational database, only without any query language. We use them to manage our things like equipment, attribute values, quests, buildings, everything designers want to put into a giant list. For us, editing these, though, got very tedious as our data scaled up, and we got closer to early access. As you can imagine, for batch changes, we would do export, import into Google Sheets. One bonus, though, is that we got to use, with Unreal, was data validation. One of the first blueprint examples I showed you was was the editor tool. What we ended up doing was writing a bunch of this data validation in blueprints as well. And this saves a lot of QA and designer time because they can actually keep that data validation updated as the schema changes with the gameplay features. If we had to do it again, I'd want to invest a few weeks up front to build a means to automate this, the import-export process specifically, or look for a plugin. It's generally how we're used to working in Unity, and it's how our designers kind of really like to work, put everything into a data table. If our team is bigger, or we're working on something more data-heavy, like an RTS or simulation, then what I want to do is create a layer of abstraction between Unreal and whatever data management solution they want to use, which, let's be real, would be Excel. All right.
All right. So in short, I guess game development can be frustrating and torture and hell, but at least it's not this. Oh, wait. Oh, do we have sound? I don't want sound.
You can't grapple on kaiju.
Try.
So this is our talk. Feel free to look up me and Sora online, QR code with some links and resources, and yeah, that's really all it comes down to. So feel free to ask questions. We'll wait around and chat for a few minutes as well.
Yep.
So we do have a bit of time for questions if there are any.
Yeah. Thank you.